Hi, this is an etched PCB board and the circuit is of a simple, powerful inverter.
Next level. Next level.
So guys, the circuit is finally complete and I'm going to use this 12 volts 7 ampere hour UPS battery to test it. So the first test is going to be the AC output voltage measurement. Okay, so watch the display of the multimeter screen. The voltage is beyond 1000 volts, which can easily damage my multimeter. So let's resume the test with a load connected in between. So for doing this test, I'm going to use this 18 watts LED to 20 volts. Okay. Yeah. So as you can see that it is flashing 165 volts and that is low because my battery is discharged. But yes, it is working quite well. So here I'm showing you three scenarios. The first one is when no load is connected. You see this wire is not connected. So the battery voltage is 12 volts. Now there is no bulb connected over here. So the inverter is not loaded. Let's see the drop. You see, it is 11.24 at no load. Now let's connect this bulb and then check the drop in battery voltage. You see, it is only 10.4 volts and dropping as low as 8 volts, and that was the reason because of which the output voltage was only 170 volts. Therefore, some recharging time. So after some time, you can see the new battery voltage is 12.5 volts. So let's do the test again with a 100 watts bulb. Okay. Let's turn off the lights. Let's turn off this light too, and quite bright. Beautiful. Continuous. Whoa. This video is sponsored by ELECROW, which is providing services for mechanical keyboards like its PCB assembly, 3D printing its cases, and its laser cutting. They're also providing $50 coupon to anyone who shares its PCB assembly production video, and there is also a reward system for new customer registration and friends invite. Check them out from the link provided in the description below. Hi, this is a laptop charger, and its output voltage, as you can see, is 20 volts DC. Therefore, I'm using it to charge my cordless drill battery. Now, for charging any 12 volts battery with this laptop charger, you will need to reduce the voltage from 20 volts to 14 volts. So I got this new product from DF Robot. As you can see on its label, it is a DC to DC buck boost converter module, 5 amperes. So let's open it up, look what's inside, and test it on this project.
Next level.
So here, as you can see, I've connected my laptop charger to my buck boost converter, and the output voltage, as you can see, is 10.5 volts and 0 amperes. So let's connect some load to it. Now let's remove and see the open circuit voltage. It is fixed to the same 13.8 volts. Now let's move on to charging our 12 volts UPS battery. Here, as you can see, that the current has increased to 1.5 amperes. Now let's try and increase the current. Yeah, the current is reducing. You see, let's go lower and lower. It's 0.5 amps. Now because the current is less, so the voltage is also dropping. Let's go more low. And we have reached 0.18 amps. Let's move on to full value. Let's go maximum. Yeah, this is the maximum that this battery is drawing. Look how it is maintaining the voltage, constant 13.8 volts. Now I'm already using this laptop charger to charge my drill battery. So instead of this laptop charger, I will be using this 24 volts 2.5 amperes power supply. So here, as you can see, that the battery charger is fully complete and it is working quite fine on this 12 volts car headlamp bulb. So let's test it on our 12 volts 150 ampere hour inverter battery. Now this, what you see, is my 1500 watts inverter, and these two blue wires are 10 mm wires which are connected to my inverter battery. As you can see, the blue wires connected to the terminals, and the battery is 150 ampere hour. Now if we look at its battery voltage, it is 12 volts exact, so it needs charging. At present, the power supply is not connected, so it is flashing 11.8 volts. Now let's connect the charging cable and see how it is charging. So the charging, as you can see, has started. The voltage has increased to 12 volts and the current drawn is 2.45 amperes, and now it is 12.1. Let's increase the current. You can see the voltage is increasing. So the current is increasing. We have reached 3 amperes and it supports maximum of 5 amperes. So here we are doing 4 amperes. Now this should be enough for safe charging. Yeah, it's not hot at all. No heating. That's pretty good. And the voltage has increased to 12.5 volts. Link to buy this has been provided in the description. Similarly, to charge your 9 volts, 8 volts, 3.7 volts or 1.5 volts battery, all you got to do is set the battery voltage and connect the battery. So here, as you can see, that the battery is drawing as high as 1.3, so it is charging. So similarly, you can also use it as a DC motor speed controller. Thirty-two volts.
Next level.
Seems like there is some issue. Now here, as you can see, my new smart digital multimeter from Kaiweets, model KM601. So let's open it up. User manual. Very nice case. So that's our multimeter. High quality cables, batteries, extra batteries, temperature testing unit, and the meter itself. The case itself is really good. Well, this multimeter is quite rugged and looks more like a mobile phone. Here's the cover. I think it is removable. Yeah. Okay. It was quite difficult to remove the cover. Sturdy look. And here we have it. Okay, so here are the connection points, and let's plug in the batteries first. Okay, I think I will have to open this point. Yeah. So these are the battery points, 3 batteries. It's good that they have provided us extras. Positive side, okay. So here I'm giving you the close-up, auto and function, pressing it once, DC and AC voltage mode. And it is also flashing the temperature of the environment around it right now. Next is the resistance, continuity. You see here it is written manual. Next, diode, capacitor, voltage in millivolts, both AC and DC, frequency. Next is temperature, and this is NCV. This I will tell you what it is. Current in milliamperes and amperes. If you press it again, it is going to move on to the smart mode. You see, it is going to detect automatically what kind of measurement we are doing right now. Next, here as you can see, it says flashlight, and here we have it. There are 2 more buttons. This is power on off, I have already shown you, and this is not a button, this is the NCV point. Now guys, here as you can see, it is saying common, so black will be connected over here. Next, you see live, ohms, capacitor, diode, continuity, voltage, frequency, temperature. For this type of measurement, the red wire will be connected here. So that's that. Now let's say that I want to measure the voltage of this lithium-ion battery. And here we have it, 4 volts. It has automatically detected that we are measuring voltage here. Okay. Next, let's go for manual voltage measurement. Now for manual voltage measurement, you can see that it is guiding you that you have to connect red and black wires over these points. Okay. Yeah, and again we have 3.986. Okay, I think this is going to come out. Nice. Next, I have this 1 kilo ohm resistor. Let's see its resistance. Oh, sorry, it's not in the auto mode. 987 ohms. Continuity. Diode. 6 amperes diode. Reverse bias, and here we have 0.5 volts. Next, I have this 2 kilovolts capacitor. So it is 7.5 nanofarad. Next is frequency. So here I have this 220 volts AC supply, and here as you can see the frequency is 50 Hertz. Next, we already know the temperature, it is 26 degrees. Moving on to NCV live. Now this is what I was talking about. Let's remove the wires. So here we have the cable, nothing. So you see, this side is neutral. I will show you. It is somewhat like this. So this is the point. Nothing. Close up. Very little beeping. And here. So this side is live and this side is neutral. So it is measuring from quite far distance. That's nice. Now let's move on to ampere measurement. So here is flashing, common and 10E. Connecting one wire to the supply. Now let's connect this 12 volts bulb. So it's drawing around 2 amperes, 2.052, and same there, 2.0. So the current accuracy is quite good. And lastly, here we have this APO, auto power off. Link to buy this product has been provided in the description. So I have this power supply. Here as you can see, 4.5 volts. So that's our simple LED chaser. Let's turn off the lights. And that's the potentiometer with which we can manage the speed.